So again, yesterday's lesson has nothing to do directly with solving quadratic equations. It's about building your mathematical muscles in terms of factoring. Does anybody have any questions you would like me to go over? Go ahead, Lucas. Certainly. Let's take a look at question 4. We're asked to factor this polynomial. And again, I just want to point out to you, let me rewrite it first. It's 16a to the 8 minus 65a to the 4 plus 4. And I'm going to throw in an a to the 0 here just to make a point. Okay. I'm pointing out to you to begin with that if this thing is factorable, we will have a number of a to the 4s and a number of a to the 4s, and we will have some other number here and some other number here. Okay, and there's plus or minuses, but I'm not really concerned about that. My point is, if you FOILed this out, the product of these are going to give you a number of a to the 8s, which is what we want. Okay? The product of these is going to give you a number, which is what we want. We want the number to be 4. The product of these and the product of these are going to give you numbers of a to the 4s. Running out of symbols to use here. But you're going to get a to the 4s, and when you add them together, you'll get a to the 4s. I think once you see all of that, you understand why this needs to be even. This needs to be half of the even number at the beginning, and this needs to be 0. That's kind of the template for something being quadratically factorable, if that's a phrase. So it qualifies. Now, I happen to have a little bit of an advantage with this question over you, not because I have more experience, but because I did it at lunch with a different student. So the advice I would give you is to persevere, because when I did it at lunch, I couldn't get it right away. I really couldn't. I tried 4a to the 4 and 4a to the 4, and had I been in a better frame of mind, I would have known that that's not possible. And here's why that cannot be how it's going to factor. Because the 4 at the end has to be broken into two pieces that are written here and here. And I only have two choices with that stage. I can put a 2 and a 2. But if I put a 2 and a 2, well, I shouldn't say, yeah, it is impossible. If I put a 2 and a 2, then I'm not even going to FOIL this out. I know that can't be right because this has a common factor of 2, doesn't it? And when I look here, this is my eyeball. When I look here at this, there's no common factor of 2. So it can't be 2 and 2. Well, maybe it's 4 and 1, but you see the problem still exists. Because if I break 16 into 4 and 4, 16a to the 8 into 4a to the 4 and 4a to the 4, I'm going to have an even already in both of those factors. And there's no way I can avoid, that should, I guess, be a 1. There's no way I could avoid getting an even with the 4 at the end. So that tells me, and to the people I was working with at lunch, I worked with 2 people at 2 different times on this question. That tells us that this is 16a to the 4 and this is 1a to the 4. But it didn't occur to me until just now that that tells me I shouldn't even try 2 and 2, should I? Because I would be stuck with creating another common factor. And what I did at lunch, strangely enough, with the 2 people separated by 25 minutes with the same question, is I tried 2 and 2 and then I gave up. I went, is this factorable? but I didn't persevere. I didn't say it probably 4 and 1. And if it is 4 and 1, then the 4 better go here. Otherwise, I create another common factor with the 16. And we discover that if you FOIL that out now, your outer product is 4 times 16a to the 4, which I believe is, well, it's negative, but it's negative 64a to the 4. And my inner is negative 1, so there's my negative 65. These are both, though, differences of squares. So I can factor this into 4a squared plus 1 and 4a squared minus 1. And I can factor this into a squared plus 2, a squared minus 2. I cannot factor this. There's no such thing as a factorable sum of squares. But I can factor the next binomial into 2a plus 1, 2a minus 1. A squared plus 2 is not a difference of squares, so I can't factor it. Is a squared minus 2 a difference of squares? Not in this course. Okay. And we're done. As we talked about yesterday, you could write that as a plus root 2, a minus root 2. Go ahead. Can you repeat that, please?
Why can't you, like, do the difference of squares thing to both of the 4a squared plus or minus 1?
Okay. So your question is, why can't we factor that? Am I correct? You can try, and many people have over the years, but it's not possible. So let's say you thought it's going to be 2a and 2a, right? It's got to be 1 and 1, right? You have 3 options here. We could put plus in both of these, but I hope you see if you FOIL this out, you're going to end up not only with 4a squared and 1, but you're going to also end up with 2a and 2a, you're going to end up with 4a. Your third option is to do this. By the way, neither one of these, well, this is a possibility maybe because negative 1 times negative 1 would give you 1. But if I FOIL this out, I get negative 4a in the middle term. The only way you can get, I don't want to mess this up too much, but if I put 0a here, which is what we have, you know what, I'm going to rewrite this. 4a squared plus 0a plus 1 is what we're factoring, right? The only way you're going to get the 4a squared is to have 2a and 2a. The only way you're going to get 1 is to have 1 and 1. And the only way you could get 0a is if this and this are opposite of each other, which means one of these has to be positive and one of these has to be negative. But when we multiply the negative 1 by the positive 1, we don't get positive 1. We get negative 1. In other words, no matter what you do, and I'm not issuing this as a challenge to anybody, but I'm just saying, if you wanted to waste your time, you could spend hours and hours and hours trying to factor something like 4a squared plus 1, and it's not possible. Unless there's a common factor, but that's not what we're talking about. Have I answered your question? Okay, good. So, Lucas, that's where we end right there. And I think I've answered your question. Okay, go ahead.
Why are, like, for the questions where it says something like a squared plus something a and then a constant, you get
two answers. For one with an a to the third, you get three answers. So why aren't there 8 answers here?
I want to answer that by saying that math isn't always kind. What I will tell you, and I'm going to show something to you right now, it's not going to go up to 8, but I want to address this because I think it's an important question. If I don't explain it, it's going to just weigh on your mind, and you won't get an answer until next year. Okay. These are called polynomial expressions. And when you have a polynomial expression like x minus 2, there's, quote, in your words, one answer, right? By the way, answer means kind of solution, and solution is an x-intercept. Yes? So if I have a function like y equals 4x minus 9, 4x minus 9, if I put it equal to 0, and everybody's going to benefit from this. This is a great opportunity so that when you get to Math 30, you go, yeah, we've talked about this a little bit. If I said to you, what is the solution to y equals 4x minus 9, it would have one answer, and that answer would be the x-intercept. Right? You would add 9 to both sides, divide by 4, and that would happen to be the x-intercept. We have learned, and this is going to start to answer your question, that quadratic expressions, since it's raised to the 2, have 2 answers, right? But do all quadratic equations have 2 answers? Well, do all quadratic functions cross the x-axis twice? No. We can have a quadratic function that only touches once, or we can have no answers. So, the number of, quote, answers you can get with a polynomial, and that language I'm just using loosely, but the number of, quote, answers you can get, or x-intercepts, or factors, or solutions, can be the highest exponent, or it can be smaller. So as a further illustration, and I only go up to an exponent of 5 here, not 8, but here is an example of a polynomial expression or a polynomial graph that's x to the 5. And you can see there are 1, 2, 3, 4, 5 x-intercepts. And if you were to factor this beast, you'd have 5 different factors. Okay? But it's possible, just look at that shape. Up, down, up, down, up. It's possible to have that shape. I'll go to this one. It's possible to have that shape, but it doesn't cross in 5 places. It only crosses in 3. And what this means, and there's exceptions to what I'm saying, but I'm answering this in a general way, is that whatever the equation of this is, and there it is, if you're interested. If you factored it, and again, what I'm going to tell you is not exactly true, but it's good enough. When you factored it, you'd only have 3 factors because there's only 3 x-intercepts and there's only 3 solutions. So the bottom line here is, and it's more complicated than this, but since this is raised to the 8, it could potentially have 8 factors, but it could have fewer. So that's why we have, and by answers, I think you might have meant factors, right? Yeah. We only have 1, 2, 3, 4, 5. But what's interesting is the highest exponent in each of these factors, those all have to add up to the 8. It's just that these 2 at the end have kind of 2 factors in them somehow, but since they're not factorable, you can't expose them. Have I kind of answered it and given you something to think about? Good. Does anybody have any other questions from the assignment from yesterday or in general? Yeah. 5? Okay. Is there a particular one in number 5? Okay. So all of these are complicated for 2 reasons. One, they're complicated because of this thing here. So it's this green thing squared, and it's the green thing raised to the 1. But they're complicated as well because of the coefficient in front, which is 4. So I would recommend here, and I gave some thought to this last night, I may have come across yesterday as saying, I don't think you should have to substitute something in here. But I think maybe my advice was wrong. So if we want to factor this, then let's replace that green thing with G. G for green. Okay? It doesn't matter what that green thing is. This quadratic expression is 4 times a thing squared minus 5 times a thing plus 1. So this is factorable. We're going to talk a lot over the coming days about that whole b squared minus 4ac thing. But everybody, we don't need to do b squared minus 4ac here. I'm telling you this is factorable. So I'm guessing it's going to be, I can see my guess is wrong. I would try 2g and 2g and 1 and 1, and that's not going to work. Do you see I can't get negative 5g out of that? Okay. It's funny how I started off with this factoring by saying, it's 95% of the time it's 2 and 2, and lately it seems in the past couple of days it's been 4 and 1 all the time. It's just the way the cookie crumbles, as my dad would say. So it's got to be 4g and 1g. And if we make both of these negative, do you see that if I FOILed that out, I would get this expression? So this is the factored form of 4g squared minus 5g plus 1. But this g thing was just a crutch that we created to lean on so we could factor it. G is actually that green highlighted thing. So now I'm going to replace the g here with 3x plus 1. And get 4 times 3x plus 1, then minus 1, and then 3x plus 1 minus 1. And now what we're going to have to do here is simplify what's inside of each of those brackets. So for example, this is 12x plus 4, and we're subtracting 1. This is 3x, because 1 minus 1 is 0. We can simplify that a little bit more. 12x plus 3 times 3x, because the 4 minus 1 is 3. And then we notice that there's a greatest common factor in the 12x plus 3 of 3, and then we get 4x plus 1, and then we have our 3x. Now, everybody, normally when we say factor, we don't multiply the factors together, right? That defeats the purpose of having it factored. But when you have a monomial and a monomial, we put them together. So rather than writing 3 and then 3x later on down the road, we just write 9x. So the answer to this question will be 9x times 4x plus 1. And that's what you would do for any of these. I would recommend replacing that thing that's being squared with some other variable. Is that okay? Okay. And again, this is what I mean by, I think I said this, it's been a long day. This lesson, it was about giving us a mathematical workout and getting our algebra skills up to the next level. All right, we're going to get started here on the next lesson. Just when you thought you escaped from completing the square, like a zombie, it rises to present itself to us again. So we're going to be solving quadratic equations by completing the square. And I want to set your mind at ease here. There's two reasons why we're going to be solving quadratic equations by completing the square. One of them is the same reason we did what we did yesterday. It's to get better and better with our algebra, okay? I'll be honest with you. That's one of the reasons. The other reason is there's a much better way to solve quadratic equations than completing the square. But in order for you to understand that better method, you have to first start by understanding this. So in the end, everybody, I'm going to tell you that at the end of the unit, there are going to be 4 ways you can solve a quadratic equation. Graphing, completing the square, factoring, or using something called the quadratic formula. Completing the square is never what you would want to do. I've never in 30-some years met a student that goes, yeah, boy, I really like completing the square. They don't exist. Okay? If you do, then you're unique. And that's not an insult. That just means that I've never encountered you before. So we're going to solve these equations by completing the square. As a warm-up, let's review a few things here. Solve the following algebraically. Is equation A a quadratic equation? Sure, because it's got an x squared. There is no special math required to solve this. You just rearrange for x. Because there's no x term, there's only an x squared term. All you have to do is subtract 5 from both sides and get 2x squared equals 32. You can divide both sides by 2 to get x squared equals 16. So x equals root 16. Which means x equals 4. So I'm going to ask you if you are okay with my work. Am I right? If I gave this to you on a quiz and you wrote that, would I give you full marks? Nope. What's wrong? And it's not that you're not showing work. I've done something wrong. Goes back to Sasha's comment about how many answers we should get. This is quadratic. Shouldn't we get 2 answers? How come we're only getting 1? No one? Right. When you take the square root, you go plus or minus. So it's plus or minus 4. Now we can check that out. If you take 4 and square it, you get 16. 16 times 2 is 32, plus 5 is 37. It works. If you put negative 4 in and square it, you still get 16, so you still end up getting 37 in total. Let's do this one now. I would personally rewrite this equation with the quadratic term on the right side so that it's positive. What am I going to have then? I'm going to have 11 plus 16. So I'll get t squared equals 4t squared equals 27. Are you with me on that? So I divide both sides by 4 and get t squared equals 27 over 4, which means t equals plus or minus the square root of 27 over 4. And now we're going to review some things from Math 10C. One of the things we need to know is that when you square root a fraction, you can square root the top and you can square root the bottom. So that's the first step, is to understand that that square root can be distributed. And we're not really doing anything on the calculator here. We don't want decimal values. The next thing that we can recognize is that the square root of 4 is 2. Now, we've done this next little bit of business that I'm going to ask you about before. Can you tell me what the square root of 27 is equal to? So if I give you a piece of paper, I say, write down what the square root of 27 is equal to, what should you write? Square root of 27, because the square root of 27 is an irrational number. It's got an infinite number of decimals. But we have learned, this is from Math 10C, that things like the square root of 27 can be simplified. Now, I want to spend time here going over the two ways to simplify it. If I taught Math 10C, what I would tell you is that we want to break 27 up into two numbers that multiply together, and one of them needs to be a perfect square. So I want everybody to come up with two numbers that multiply to give 27, where one of them is a perfect square. And it's not that difficult, because I think they're the only two numbers other than 1 and 27. 9 and 3, right? So the square root of 27 can be written as the square root of 9 times the square root of 3, but the square root of 9 is 3. So I can write root 27 as 3 root 3. And I can tell by the looks on your faces that many of your Math 10C teachers didn't teach it to you that way. So, how many of you in Math 10 had teachers who said the following? And I know Miss Allen does this because I was just in her class the other day observing her, and she was doing this. That you take the 27 and you break it up using a factor tree or something into all the numbers. How many of you were taught that? How many of you had Miss Allen as 10C teacher? Miss Russell? Mr. Hetlinger? Flynn? Anybody else? I guess that's it. So then, and this is, I've never heard her say this before, but as I was just saying, I was in her class yesterday, I think, and she says, and you pull the buddies out. Does it ring a bell for you Christy Allen students? So buddies mean if you have a pair of identical things, they go out and you write it once on the outside. And I wouldn't have used the word buddy. I would say, well, since you're taking the square root, you identify a pair and you write the single piece of the pair outside, and the leftovers are left over. That's the language I would use. So anyway, we have to start working with that. These are the values of t. T equals 3 root 2 over 2, or t equals negative 3 root 3 over 2. Okay, let's continue with some review here. Solve this quadratic equation by factoring. This is really like you look up in a high school math dictionary, stealing candy from a baby, they'll have a picture of this equation. It's so simple. It better be so simple by now. You're looking for, I better not get it wrong now, eh? You're looking here for two numbers that multiply to give negative 12. Be careful here. Multiply to give negative 12 and add to give positive 4. I'm thinking 6 and 2, positive 6 and negative 2, yes? So then that means that x equals 2 and x equals negative 6. Can we finally, when we're talking about math and learning about it, stop writing x minus 2 equals 0? Can we do that? You understand how to go from the middle line in green to the final line here? Okay. It says confirm the solutions by substitution. Well, okay, if I put 2 here, and here, do I get 0? Well, 2 squared plus 4 times 2 minus 12. That's 4 plus 8 minus 12. That's 0. Works. If I put in for x negative 6, I would have negative 6 squared plus 4 times negative 6 minus 12. That's 36 minus 24 minus 12. Yep, that works. Solve it by finding the x-intercepts. Can we dispense with that? If you want to graph y equals that thing and look at the x-intercepts, you can. Will you believe me that I'm not trying to hide something from you, that you will get those 2 x-intercepts? Okay. So now, part B of this warm-up, can we solve this equation? That's not what you have, is it? Do you have minus 10? Thank you. Is it still x squared plus 4x, Lucas? Okay. Can you solve this equation by factoring? Well, let's go to our friend b squared minus 4ac. Calculate b squared minus 4ac. Which would be 4 squared minus 4 times a is 1 times c is negative 10. I guess that's 56. Which is not a perfect square. If it's not a perfect square, Jack, can you sit up, please, and pay attention? Jack, sit up and pay attention, please. 56 is not a perfect square. Neither is what I drew. It's more of a rectangle, but that's okay. 56 is not a perfect square, which means it's not factorable. So it cannot be solved by factoring. Are there solutions? How many of you know, by looking at b squared minus 4ac and remembering something I told you yesterday, that there are solutions? What is it about b squared minus 4ac, Myron, that tells us there are solutions? It's positive. And by the way, if it's positive, there's going to be 2 solutions. Positive meaning more than 0. So how do we find them? Well, we solve this graphically. So we're going to graph y equals x squared plus 4x minus 10. We're going to choose zoom standard and use the 0 function of our calculator to find the x-intercepts. I'm going to adjust my window settings slightly. You don't have to do this. I just wanted a better picture of the entire parabola, or the general shape of it. There is one of the solutions. Here's the other solution. So there are approximate values, and you can write these down. I don't need to write them again. Their approximate values are negative 5.74 and positive 1.74. It's interesting that the decimals are the same in each of these. Any questions with B? Okay. Well, you know, and I've mentioned this before, this is a high-level algebraic math course. It's fine to learn on a graphing calculator, but we are going to learn now how to algebraically find the values of those x-intercepts, or algebraically solve that equation. And if a quadratic equation cannot be factored, they there should be, say, solved there. They may still be solved by completing the square and then rearranging for the unknown. May. But if this b squared minus 4ac, and we will formally teach this to you later, if this number is negative, you're done. There's no answers. There will be no x-intercepts. There will be no solutions to the equation if that b squared minus 4ac is negative. So what we are going to do is solve this equation by completing the square. When we did completing the square, there was a y, wasn't there? Because it was y equals, and we were trying to get it into a vertex form. It doesn't matter that there's no y. We still do the same thing. It's just that it's not equal to y, it's equal to 0. So I take that constant term and I nudge it out of the way. I don't want it to interfere with any work I'm doing yet. I make sure before I add the mystical number, before I add, thank you, it's 10, right? I have a feeling when I prepared this from my notes, I did a lot of copying and pasting and I didn't change things. Thank you, Sasha. Before we add this mystical number that completes the square, that makes it a perfect square trinomial, I move that constant term out of the way and I make sure that the coefficient of the first term is 1. Okay. Now, what do I add? How many of you remember how to take this number and figure out what to add in the blank? What do we do?
b divided by 2 squared.
Right. I have to take half of this number squared to get this. This number is always going to be b over 2 squared. So I take 4 and I divide by 2 and I get 2. I square it and get 4, and then I have to subtract 4. Because if I add 4 to the left side, I got to take it away from the left side to keep it in balance. And that means in completed square form, this is x plus 2 squared minus 14 equals 0. Good. The thing is, we can rearrange this for x. There are 3 numbers, everyone, that we need to get away from the x. We need to get rid of this 2, don't we? We want x by itself. We need to get rid of this 2. We need to get rid of this negative 14. Which of those 3 numbers do we remove first? Since there are 2 2's, I'm going to ask the question, which color do we remove first? Jack? Yeah, because it's on the outside, right? This is the whole wrapping the present analogy, that I did 3 things to x. I added 2, then I squared it, and then I took 14 away. If I want to go backwards through this process, since the last thing I did was take 14 away, the first thing I have to do in unwinding this is add 14 to both sides. And when I add 14 to both sides, and I'm going to show this work here, but again, I'm of the opinion that it kind of makes it cluttered and confusing. I'm going to now have x plus 2 quantity squared equals 14. Okay, now Jack, I'm going to stick with you. What do I get rid of now, the green or the blue? The green. I'm working from the outside in, so I'm peeling off layers until I'm left with x. So how do I get rid of that green operation, Jack? Square root. So that means I'm going to have x plus 2 equals, Jack, is this right? Nope. Lily, do you know what I'm missing here? Excellent. Plus or minus. Perfect. Because if you don't put plus or minus, you don't get the two answers. By the way, we know there are two answers, don't we? We saw them on the graph. And now I have to get rid of the 2. That's just going to mean subtracting 2. When I subtract 2, and it's just the way we write things. Oh, what's that? When I subtract 2, we usually put the number before the radical. That's just the way it's done. So x is equal to negative 2 plus or minus root 14. What does that mean? It means x equals negative 2 plus root 14 and x equals negative 2 minus root 14. Do me a favor. On your calculator, calculate negative 2 plus the square root of 14. That's pretty powerful. We're able to solve an equation and get an irrational answer. And we can't do it by factoring, because if the answers are irrational, it's not factorable. Those two statements go hand in hand. If it's going to be irrational numbers, you will not be able to find them by factoring. By the way, if you take negative 2 minus the square root of 14, should be no surprise that you get that. Capiche? All right. So we're going to try 4 examples here. Given that I did have some transposition errors in this document compared to yours, can you double check to make sure that this is correct? Okay. Excuse me. Okay, sorry about that. So we want to complete the square here, because that's what we were asked to do. Okay, I want everybody to figure out what number we're going to add in the blank. Thomas, what are we going to put in that blank? It is 9. We take negative 6 and we divide it by 2 to get negative 3. And then we square it and we get 9. So I need to immediately correct that and subtract 9. And what I end up with is x minus 3 squared. Don't forget that half of that number in front of x is what goes in the brackets. Minus 36 equals 0. So I don't think I need color coding here. I want to get rid of the 36 first. Then I want to get rid of the squared. Then I want to get rid of the number that's right next to the x. So I add 36 to both sides and get x minus 3 quantity squared equals 36. I take the square root, correct? Come on, you guys. Plus or minus, good. This is interesting. By the way, I'm not upset when I go, oh, come on, you guys. This is interesting because root 36 is 6, right? Okay. So I get x minus 3 equals plus or minus 6. which means when we add 3 to both sides, I get 3 plus or minus 6, which means x equals 3 plus 6, and x equals 3 minus 6. But these are rational numbers. And I just said a minute ago, if it's rational, you can factor. We could have factored this. And many of you are looking up at the question now and going, well, of course we could have. Because this factors into x minus 9, x plus 3 equals 0. So x equals 9 and negative 3. Let's try another one. Any questions with that one? T squared plus 9t minus 7. I'm kind of throwing out a whole bunch of ideas here. Can you do me a favor and calculate b squared minus 4ac? Just for kicks. Let's just see what we get. I want to say 109. So 109 is not a perfect square, but it is a positive number, which means there are going to be two solutions. They're just not going to be rational. So now I'm telling you something else. I'm putting everything together. If there are two solutions that are not rational, it won't be factorable, which means b squared minus 4ac will be a positive number that's not a perfect square. Whew. There's a lot of information flying around there. Anyway, let's complete the square. T squared plus 9t plus some mystery number. Then we'll have minus 7 equals 0. I know that many of you want to work in decimal, and that's fine. But I also know that when you're completing the square with fractions, you guys are really good at it. Because there were 2 questions on the exam in the last unit that had completion of the square with fractions, and you guys did very well. So I need to take and put 9 divided by 2 squared in here. So I get 81 over 4, which means I have to subtract 81 over 4. And as we go through the rest of this example, feel free to use your calculator as long as you convert your numbers back to fractions. Okay? So this will be t. Don't forget what I said. The number you put here is half of b. So this is plus 9 halves. And then we have minus, I think we're going to get minus 109 fourths. But you can confirm that on your calculator. Yeah? One confirmation, 2, 3. Okay. This is equal to 0. Oh, okay, we can start to move things around. I can move the 109 fourths to the other side where it becomes positive. I can take plus or minus the square root. Before I move that 9 halves over, I want to point out that this is plus or minus root 109 over 2. Because the square root of 4 is 2. I can square root the top and square root the bottom, but I can't really square root the top because the square root of 109 is the square root of 109. Do you remember when we took the 27 and we broke it up into 3 root 3? I don't think we can do anything with the 109. I don't think it's divisible by a perfect square. Now I can move that 9 halves over and get t equals negative 9 over 2 plus or minus root 109 over 2. So we end up with t is equal to negative 9 plus or minus root 109 all over 2. There's a common denominator here of 2. They're both over 2. So let's put them together with a common denominator. Now, I'm putting very important there for my purposes, because tomorrow I want to come back to this question and go, look at that. There's going to be something amazing we'll notice about this. But one thing I want you to notice about this is that the number underneath the square root sign is b squared minus 4ac. And it will be. It won't always be. There's weird cases where it won't be. But it's not a coincidence that that's b squared minus 4ac. So what are our answers? Our answers are, and we can calculate them, negative 9, watch how I calculate this. Negative 9 plus the square root of 109 equals divided by 2. There's one of our answers. If I want to do it in one shot, then I would have to say bracket negative 9 plus root 109 n bracket divided by 2. Okay? But there's one of my answers. If you wanted to know it in decimal form, there's the approximate value. If I wanted to know the other one, I would repeat the process, but I would use minus. I would use minus. One other thing, and I'm just going to throw this out. When I say that, I mean, I hope that some of you get it, but if you don't worry about it. Do you see that this is an irrational set of answers because you cannot take the square root of 109? If you could take the square root of b squared minus 4ac, because it was 64, if that highlighted thing were 64, then our answers would be rational. But that means it would have been factorable, because b squared minus 4ac is a perfect square. This is kind of going around in a circle now here. There's a reason why that b squared minus 4ac is important. All right, I think we have just a couple more. Let's just skip 3 and let's do 4. I think you get the idea, but we'll do one more. This is a good one, though, because can I add a number right now to make this a perfect square trinomial? What do we have to do first? Shannon, do you remember? Right, and we're only factoring the 2 out of the 2 terms that have x's. We want to make sure that we have 1x squared. Then we can worry about adding our number. What number are we going to add? We're going to add whatever 9 divided by 2 squared is, which is 81 quarters. Are we good with where I got the 81 quarters from? Why is this wrong that I'm about to write? Well, we have our plus 9, right? Why is this wrong? It's the one area where no matter how good you are at completing the square, it's common to make this mistake. Lily? Oh, actually, the order that I put them in doesn't matter. That's not it. I'll give you guys a hint. When I wrote plus 81 over 4, I didn't add 81 over 4. You want to? And you're right. I have to multiply this by the by the 81 over 4. That's what I've really added by writing that in there. It's the one thing that's very easy to forget, that you have to multiply what you factored out by what you wrote in. And that gives us 81 halves. You can confirm this on your calculator. I know you guys are calculator driven. That's fine. 81 over 4 times 2 will give you 81 over 2. So I have to subtract 81 over 2. So now I'm going to rewrite this as 2 times x plus 9 halves, quantity squared. And then I need to figure out what this thing is. And I want to say negative 63 over 2. Am I right? Okay. Now we still have a bit of work to do here, because this time, everybody, I got to get rid of this somewhere along the road, don't I? And I have to get rid of this somewhere along the road. And I have to get rid of this somewhere along the road. But I also have to, sorry for the brightness, I also have to get rid of that. So I think it's pretty clear that we get rid of the blue one first. We can't start to attack that mess until we get the blue one out of the way. So we end up with 2 times x plus 9 halves, quantity squared equals 63 over 2. I want to check something here. Yeah, we're fine. Okay. Now, what do I get rid of now? Let's see. Let's do it this way. What do I get rid of now? Myron? The what? The 2. Which 2? There's 2 2's. Yeah, the pink one. I can divide both sides by 2 and get x plus 9 halves, quantity squared, equals 63 over 4. Over 4, because I'm dividing by 2. Now I can take the square root. So x plus 9 halves equals plus or minus root 63 over 4, which is root 63 over 2. You're going to be really surprised how often the bottom of that fraction, no matter what the equation is to begin with, the bottom of the fraction ends up being a perfect square, which is really weird. And that is also going to be helpful because you're going to realize that you'll get a common denominator when you finish your last step. So this will be x equals, I'm going to subtract 9 halves. So x will equal negative 9 plus or minus root 63 all over 2. I just want to check something here. Finally, and it's, I don't apologize for this. It is what it is. By the time you get to grade 11 and grade 10 or grade 12 will be even worse, you're still carrying all those other things that are expected from grades 1 through 10. And one of the things that's expected is you can simplify root 63. 63 is 9 times 7. The square root of 9 is 3. So we can write -9 plus or minus 3 root 7 all over 2. Those are our answers. Can you calculate b squared minus 4ac for me? It's not 63, is it? But if you divide it by 63, you get 4. So you could take the 4 out of that, and the 63 is still in there. You'll start to gain an understanding of what's going on tomorrow. But in the meantime, this is your practice. And if you're starting to maybe think ahead, remember I said, man, this is important, this one here. Look at the front cover of your unit handout. This was for solving the equation t squared plus 9t minus 7. So b is 9. This is negative b. If you're looking at the front cover of your handout, you see the significance of that. Plus or minus the square root of b squared minus 4ac, it says on the front cover of your handout, all divided by 2a. Well, a was 1, 2a is 2. Once I teach that to you tomorrow, which is called the quadratic formula, we will never have to complete the square again to solve an equation. So you got some questions to practice for tomorrow. I might give you a 1-question quiz tomorrow. I might. We'll see. What's the deal with seminars? What seminar was today? Oh, tomorrow is not our seminar. Our seminar will be Monday. Okay. So get to work on these. I'll come around and I'll help you out.